Hey, this is Schuyler from themixingprocess.com, and we are going to have a short science class today. So we're going to learn about how sound actually works, how it travels, and how we can use different tools to manipulate sound in the mixing process. So this is going to be helpful because, you know, as audio engineers, we use all these tools all the time, like EQs, compressors, all these different things. And sometimes we use them and don't really understand how they work because we don't really understand much about sound to start with. So today we're going to have a really basic walkthrough of how sound actually works. So sound occurs when two things meet each other and cause impact, and they cause a vibration. So think of a drum, and then you've got a drumstick, and when you smack that drum head, that impact causes a vibration that then spreads out in the form of a sound wave. So sound waves have two different parts to them, and I'm going to switch screens and show you kind of what that looks like. So let's say we've got our line here. Let's say this point right here at the beginning is the point of impact. So the drumstick on the drum head. When that impact occurs, it creates a vibration in the form of a wave. So we've got this wave that goes something like this, and then it just keeps going. All right, so there's two parts to this wave. As you can see, there's this part up here, which is called the compression. Then you've got this part down here, which is called the rarefaction. Now, a compression plus a rarefaction equals one complete cycle of the wave. All right. So the number of cycles in any given amount of time actually equals the frequency of the wave. So when you hear somebody talk about frequency, they're basically saying how frequent is this wave. If you think of waves kind of coming in on a shore, those waves have a frequency that they're coming in at. In the same way, when we're using frequency, we're talking how frequent is this wave kind of repeating itself. All right. Now we need some measurement of frequency because some waves are really, really slow and some are really, really fast. So we use the term in audio hertz. You've probably heard that before. The term hertz is a measurement of frequency of the wave. Okay. So when we say something is 50 hertz, we mean that wave is cycling at 50 cycles per second, or 50 hertz. So this is where this actually becomes really helpful to us. Frequency is actually interconnected with pitch. So when we have something that's really low frequency, like our 50 hertz example, 50 hertz is pretty low on the frequency spectrum. And so that frequency is going to have a really low pitch. That wave is going to be really slow, and as a result, it's going to have a low pitch. Now, on the other side of the spectrum, if we've got maybe a wave that's 1K, that is going to be a really quick wave. It's going to be cycling very, very quickly. And as a result of that, it's going to be a higher pitch than 50 hertz. So the further we go up in hertz, the higher the pitch goes. All right, now this is helpful because when we are using a tool like an EQ, let me open one up here. The human has a hearing range of typically the accepted range is about 20 hertz to 20,000 hertz. So when you look at an EQ like this one here, you can see this one comes down to about 16 to 20 hertz is the lowest you can work with on this EQ. And up at the top, you've got slightly over 20,000 hertz that you can work with up there. So that's why EQs are modeled around that specific range of frequencies, because that's usually what humans can hear and perceive correctly. Now, when you understand what hertz means and what frequencies are, this tool makes so much more sense, because when we have a bunch of low-end feedback happening, usually our response is you grab a high-pass filter like this one and you start sliding it up like that, and it cuts some of those lower pitched, lower frequencies out of that specific channel. Or if you have a really harsh frequency on a vocal, a lot of times we'll start reaching up here and we'll start carving some out in these areas up here because we understand that higher pitches correspond to higher frequencies. So that's why this concept and understanding this is helpful. It kind of gives us some depth and understanding what these tools do and how they work. How can we use them in our mixes to help get us the results we want? Hopefully that all made sense to you. If you have any questions at all, you can ask me in the YouTube comments below. You can also go to my website, themixingprocess.com, and email me directly from there. If you are a beginner engineer and you're trying to learn the basics of mixing, I'd encourage you to go to my website, themixingprocess.com, and there you'll find the 7-step mix, which is a free download guide that I made just for beginner engineers. It'll walk you through the very basics of mixing with EQ, compression, gain structure, all those different things. And it'll give you a systematic process to follow in your mixes to help give you more consistent, better results in your mixes. So go give that a download. You can ask me any questions you want. I'd be happy to help you answer them as best as I can. Thanks for watching this video. We will see you next time.